Hello, hello, and I'm late today. I was trying to do something with the help of a Coursera course. linked give a add a link to the course in the description. It's a pretty nice course, but that had some documentation with respect to or some knowledge with respect to the frame buffer, but it was taking some time. So anyway, we will do both approaches, as in we will. So I was thinking I'll make use of that approach, and then once I have a result, I will actually finally stream it. But as it happens, I was also getting a bit fidgety because I was getting a bit guilty that I was not streaming anything, and why am I getting two audios? One sec, let me check. There is some issue with my audio. One sec, there is some issue with my setting. Uh, why am I getting two audios? One sec, let me check. There is some issue with my audio. I think this is sorted now. One sec, there is some issue with my setting. This is sorted, I guess. I'm not sure why this was coming in the. Uh, yeah, so I think this is sorted now, I think. Uh, yeah, so there is some sort of therapeutic feeling while you do this. That is why I think this was. I was missing this, and there was some sort of guilt also associated with it. It also gives you a feeling that you are productive, is what I feel. Maybe it is just the new person's high or whatever, as in because you're doing it for the first few times, you will feel some sort of happiness with respect to it, which will fade away eventually. But anyway, it feels nice to do this, so that is why I'm doing it also. So yeah, and it is stuff I like also, so it's a win-win anyway. um, yeah, so where were we yesterday? We had reached a point in which so the problem statement currently was we were um, trying to show a sequence of diagrams in which the water droplet itself was moving. But this was not happening because we don't manipulate the texture itself, right? We only manipulate the what is shown in the screen, and the texture itself, which is loaded into the memory, is not manipulated during the shader code, and because of which there is no consequent movement consequent frames with movement that is happening. This is something that we identified yesterday. I mean, this is so obvious now, but yesterday I think we were not up to it. And now what we have to do is make sure that we are able to use a frame buffer. This was something that was challenging. So I have decided to do two things. There will be like maybe a 1 hour stream now, in which we will basically try and try and uh, do this try and figure this out. This was with a sense of urgency, and then we will do one more stream in which we will not stop streaming until we are able to figure out uh, how we will be using the frame buffer. This will be not an urgent stream because the completion itself is the task. So urgency is inbuilt. Not we I don't have to have a sense of urgency for that. So there is a goal for the stream, and that might take some time. It is still fine, I guess, because this we have to move past now. As in, we have taken enough time. We are on the fourth day now, and we are still figuring out how to use frame buffer. So I think this has to be done today. So yeah, I think that would be the second stream. So yeah, I think these two are good enough, I guess. Currently, we will just try and do see what can be done, and in the next stream we will not be urgent, but we will make sure that we complete the thing. So we'll just see where are we with respect to the code. And the screen is going all sorts of colors now. Yeah. So we were trying to do a bind frame buffer yesterday, and we had some sort of yeah. This is in accordance with the Stack Overflow answer that we were looking, right? As in, there were 11 statements, and we were able to insert 3 4 statements. After which, one point of time, we were able to insert 4 statements, and after which we were like, wow, we were going good, and then suddenly this realization came. Then we were like, what we should do currently, how we should go about things, and all that, and we kind of got sidetracked as well. But this code itself doesn't seem complete as such, because I don't see any sort of shader code in which it is getting. I don't see any sort of shader code in which this manipulation of texture is happening. So we will first maybe try and find that code first. Man, the screen is going all sorts of colors. Let me see if this is how it is shown in the stream as well. Texture is happening. So we will first. Yeah, the screen is going all sorts of colors. Yeah, so this is some sort of issue with the laptop. I am not sure what is this. Uh, yeah, no, it's fine, I guess. Um, yeah, we will try and search that, right? I think this was indicated in some answer is what I remember. Let's just check it. This is all not very useful, I guess. I think this is the one we are using currently. Also, the most important part in all of this is, I mean, yeah, this is becoming a bit difficult, but the important part here is I should be enjoying this as well. As in, this is I have visited this concept before as well, but then also there was a lack of clarity then. Now, now we are trying to make it simple for us, right? That is why we are trying to solve a problem and using these concepts, right? So, of course, there needs to be urgency, and of course, there needs to be um, I mean, we need to take care of time as well. That is why I was saying that this should be completed. We'll try and complete it today. But one of the most important point here is you should always enjoy your victories, right? Yesterday we had a victory and we then celebrated a bit. So that part is very important here because otherwise, what is the point, right? I mean, of course, the output would look good, but anyway, that is that is kind of important, I feel. So even if we are doing a longer stream, I'll try and not beat myself up if I'm not getting an answer or whatever. I mean, we will try and navigate through all the problems and hopefully come up with a solution today for this. Yeah, so for this is the code, man. I mean, I'm not sure what to do with this code now. Mm, frame buffer, opengl, yes. Maybe we learned this concept in not OpenGL then in then maybe converted to OpenGL. That is not a bad idea as well, I feel, because there will be something corresponding to there as well, right? As in, it won't be like totally unrelated. I mean, some concepts may not work, but many concepts will work, right? So maybe we can try reading this. I think this is a very basic article, and it's from learnopengl.com as well. So anyway note down these links, right? One is this, and other one I was talking about the course, right? If anyone is interested, you can take up that course as well. But yeah, I think we should do that. Otherwise, we are doing a lot of reverse engineering. Yesterday, also, my concern was this, as in we understood something, and it is good to go like that, but it should be a mix of it, right? It should be a mix of structured learning and unstructured as well, right? So it cannot be purely one form or the other. So I think we should have some basic understanding here. So I think if we read this here, I think it will be helpful, I guess. What is a render buffer? Was a frame buffer? That is first question. What is all associated with the program? This I think we can answer now. The shaders are associated with the program. What else is there? The variables also associated with the program. This is the M program that I'm talking about, which is just an integer which is an handle to the program that we create, right? Yeah, bind attribute location. And then that's all. For variables, we use shaders, and variables are associated with it, basically. Shaders are associated with the program. The variables as well are associated with the program. Uh, yeah, yeah, that seems about correct. Now, so how will we approach this learning, right? As in what I will do, no, in this case, uh, we will just copy all the code from here. Could we do that? Is it present, by the way, anywhere? It is there. I think we'll try and comment on this code. This actually works also for sure. So we wouldn't be doing anything. Maybe we will go through the code once here. We'll first read the article. I think we'll do it in the correct way. I mean, otherwise people also will get. I'll read it out loud maybe to make sure that we are going line by line. Otherwise, what is the point? Uh, so far we have used several types of screen buffers: a color buffer for writing color values, a depth buffer to write and test depth information, and finally a stencil buffer that allows us to discard certain fragments based on some condition. Okay. There are many screen buffers: a color buffer for writing color values, a depth buffer to write and test depth information. This is an important information. We'll just note it down. Color buffer to write color values, depth buffer, write depth, color buffer, depth buffer. So what is the third one? Pencil buffer to mark certain things out of the screen. Color buffer to write the color values, depth buffer to write the depth, and stencil buffer to mark certain things out of the screen. Great. This is something that we noted down. Let's go back to the article. Okay. The rendering operations we have done so far were all done on top of the render buffers attached to the default frame buffer. The default frame buffer is created and configured when you create your window. By creating our own frame buffer, we can get the additional target to render to. Okay, there is something called render buffer and there is something called frame buffer. This we discussed yesterday also, I feel, but I think it was not quite clear. The frame buffer actually is not about aggregator of one or more attachments, which by turns are the actual buffers. You can understand the frame buffer as tree structure, which where every member is a pointer to a buffer. Without any attachment, a frame buffer object has very low footprint. Okay. Now each frame buffer attached a buffer or a texture. The render buffer is an actual buffer. The render buffer stores pixel values in native format. In other words, drawing a render buffer can be much faster than drawing to a texture. Okay. So basically, frame buffer is a struct that contains a lot of things, and many of this is a render buffer. I think this color buffer, stencil, and depth buffer were all render buffers only. And you can also draw it to texture, but apparently it is slower. So we just note down this information. Okay. Frame buffer is an aggregation of render buffers plus texture. Yeah, this is fine, I guess. Okay. Application of frame buffers may not be immediately make sense, but rendering your scene to different buffer allows us to use that crucial to create a mirrors in a scene. Okay. Or do some post-processing effects, for example. First, we'll discuss how they actually work, and then we'll use them by implementing those pooled post-processing effects. Okay. Just like any other object in OpenGL, we can create a frame buffer object by using a function called genFrameBuffers. Okay. This pattern of object creation and usage is something we have seen dozens of times now. So their usage functions are similar to all the other objects we have seen. First, we create a frame buffer object, bind it as the active frame buffer, do some operation and unbind the frame buffer, right? To bind the frame buffer, I think this also we have done. By binding to GL frame buffer, what was the command on OpenGL ES that we did? This is on GL bind frame buffer, GL frame buffer dot get 0. We did an unbind as well here, right? At some point of no, we didn't unbind, we found a different frame buffer. Okay, this is fine. Until now it makes sense because it is pretty obvious. By binding to the GL frame buffer target, all the next read and write frame buffer operation will affect the currently bound frame buffer. It is also possible to bind a frame buffer to read or write target specifically by binding to GL read frame buffer or GL draw frame buffer respectively. The frame buffer bound to GL read frame buffer is then used for all read operations like GL draw pixels, and the frame buffer bound to GL draw buffer is used as the destination for rendering, clearing, and all other write operation. Most of the times you won't need to make distinction, though and you generally bind to both with GL frame buffer. Okay. Unfortunately, we can't use our yet because it is not complete. For a frame buffer to be complete, the following requirements have to be satisfied. We have to at least attach at least one buffer, color, depth, or stencil buffer. Okay. There should be at least one color attachment. Okay. All attachments should be complete as well, reserved memory. Each buffer should have same number of samples. Okay. This we can use it in our, we have to attach at least one buffer, right, before using the frame buffer. This is something we can note down. You have to attach some sort of buffer before using the frame buffer. Yeah, this is great advice, I guess. This is not an advice, by the way. This is a requirement. I spaced out. There is a sense of urgency because anyway we are reading an article, but we have to absorb it anyway, so it is fine. Don't worry if you don't know what samples are, we'll get those in later chapter. Okay. From the requirements, it should be clear that we need to create some kind of attachment for the frame buffer and attach this attachment to the frame buffer. After we have completed all requirements, we can check if we actually successfully completed the frame buffer by calling. Okay. This is one the attachment is done. I think we also tried this one as well. This is the man. This scene is we tried this one as well, I guess. Color attachment 0, right? GL frame buffer texture 2D color attachment 0. I think this is that line, I guess. Okay. That could potentially be the line I feel. I feel. Color attachment 0 as texture 2D, right? Okay, this is potentially one of those lines, but anyway, we'll go back. Man, this has to improve. All subsequent will now render to the attachments of the currently bound frame buffer. Since our frame buffer is not the default, the rendering commands will have no impact on the visual output of your window, which is obvious. And for this reason, it is called off-screen rendering when rendering is to a different frame buffer. If you want all rendering operations to have visual impact again in the main window, we need to make the default frame buffer active by binding to 0. Okay. When we are done with all frame buffer operations, do not forget to delete the object. Okay. Texture attachments. Attachment is a memory location that can act as a buffer to the frame buffer. Textures or render buffer objects. Okay. When attaching a texture to a frame buffer, all rendering commands will write to the texture as it was a normal or color depth or stencil buffer. Advantage of using texture is that we can then easily use in our shaders. Create a texture for a frame buffer is roughly the same as normal texture. Okay. GL text image 2D. Okay, the main difference here is that we set the dimension equal to the screen size. And we pass null as the textures data parameter. Acha. I think GL text image 2D is something we have already used. GL text is not something we have used actually. GL text image 2D. Okay. What is this? During load textures, what all we are doing? We do a bind texture. We do text parameter. Oh no, text image 2D we do. GL utils GL text is just text image 2D, but we do that. Okay, here they are passing it as null apparently. We see the dimension, we set the dimension equal to screen size, and we pass null as the textures data parameter. Okay, we are only allocating memory and not actually filling it. Filling the texture will happen as soon as we render to the frame buffer. Okay. Also note that we do not care about any of the wrapping since we won't be needing those in most cases. Okay. So basically what they are saying is, so this is a question. I think this we have to answer only. Real text image 2D, how it will differ for off-screen rendering versus normal case. Yeah, because real text image 2D we are already using. I'm not sure how is it going to differ in either of both cases. But anyway, let's move on. Uh, Now that we have created a texture, the last thing we have to is attach it to the frame buffer. I think yeah, this is the thing that we have already used. GL texture 2D texture 0, right? What is GL frame buffer texture 2D? Would I give some sort of handle here? GL texture 2D. Okay. Frame buffer is okay. Color attachment is GL texture 2D is also okay. Now I think I should be giving uh, I think I should be giving this as well. Texture 0. Texture is the yeah. Texture is the just note it down. Text target attachment text target texture level. GL frame buffer texture 2D has is for attaching a texture to a frame buffer. It has the following parameters: target text target texture texture pointer. And I think this is kind of evident what is this, but what is then GL text image 2D? I'm getting confused here. Every time I'm switching screen, this issue is happening. Yeah. No, that is not happening every time. GL text image 2D versus GL text image 2D. Chronos will say specify a two-dimensional texture image. Okay. This is for the definition part, I guess. GL text image 2D is just for the definition. So that is why this is being done in the load texture part, right? Yeah, I think it is just for the specifying the texture, I guess. There is nothing more to this. The second is attaching to, this is the definition of a texture. Basically, while loading the texture, as in converting a bitmap to a texture, we just first generate the texture handle. Then we basically bind the texture 2D, and then we just, this is for the loading the bitmap. So first we create a name which is called the texture handle. Then we bind the name as the current name, which is texture 2D. What is GL texture 2D, by the way? GL texture 2D is the texture in 2 dimension. That is all. I think we can have multiple GL texture 2Ds, but it is a type, I guess. Right? I'll just a type, I guess. And we are just specifying that we have a we are just specifying that, just note it down, by the way. While loading texture, we generate a texture number, we bind the texture number to, which is the texture handle. We're just naming it, we are just making sure that we identify that it is just a number. We bind the texture number to GL texture 2D, and then we do a text image 2D to load the bitmap. Yeah, this is kind of what is happening, I guess. Yeah, this is kind of what is happening. Now, yeah, I think there is more reading that is left in here. I might have to go away for some time, and then we can visit this back. We are completing this today. We'll enjoy this. It's a challenge, but it is important to enjoy it. We shouldn't be beating ourselves up for not reaching the goal in a reaching the goal faster, but we will anyway do it, and we'll try out various things. We'll have fun, but we'll make sure that in the next stream we are completing this, as in we are using a frame buffer to render our we'll render it to a frame buffer, then from frame buffer we'll render it to our screen. That is only, we may not do any sort of manipulations as well, but we'll just make sure that we do this correctly today. Yeah, I think this stream can end currently. I'll be back after some time. Bye. Bye. Bye.